This is the brief on dynamics of work in conservative and non-conservative fields. We're tackling a fundamental question in physics here. Does the path a particle takes actually change the total work done by a force? We're going to find out by comparing two very different types of forces over two separate paths. All right, first up, path dependence, using a non-conservative rotational force. Here, the path is everything. Moving a particle along a curved quarter-circle path resulted in about 1767 joules of work. But taking a straight line between the same 2 points, the work dropped down to 1125 joules. That difference proves that for non-conservative forces, the route you take completely changes the outcome. So what's the alternative? Well, that brings us to our second point. Conservative fields. Think of a simple spring force. For a force to be conservative, the work it does must be independent of the path. It makes things way simpler because work is just tied to the change in potential energy between the start and end points. And finally, the spring force example really nails this. With that force, because the particle starts and ends at the same distance from the center, the change in potential energy is 0. So guess what? The work done is 0 joules on both paths, the curved one and the straight one. Total path independence. Ultimately, this is the key difference. Conservative forces care only about the start and finish, while for non-conservative forces, the entire journey matters.